Hello and welcome back to A Software Engineer Plays, the YouTube channel where a software engineer plays through video games designed to teach you aspects of logic, reasoning, programming, software engineering, all that good stuff. We are back in Human Resource Machine yet again, and we are on level 40 here, the Prime Factory, which, basing off the name, I'm guessing we're going to be dealing with prime numbers, which are very important. I think we talked about prime numbers earlier. I forget exactly where, but prime numbers are really important in computer science, especially when it comes to things like cryptography, because it is relatively easy to multiply two prime numbers together, but when you have a very, very large multiple of two very large prime numbers, it becomes very, very difficult to find out what those prime factors of the number was. And that is the basis for a lot of the modern cryptographic algorithms which keep your internet and credit card transactions secure. So prime number is super important. If you want to go do some research on cryptography and prime numbers, you can look at Euler's totient function and learn about the RSA encryption algorithm. It's all really, really cool stuff. Pretty complicated mathematically, but it gives you an idea of how prime numbers are used in computer science and in cryptography to keep you safe while you're out there buying things on the internet and sending data back and forth. Anyway, let's jump into the level, the Prime Factory here. Year 40. Are you sure you're supposed to be here? This is a very difficult assignment. I have no idea how to do it either. Okay, so for things in the inbox, send its prime factors to the outbox in order from smallest to largest. Alright, so we're doing prime factorization here, which, if you don't know what prime factorization is, basically any number can be expressed as a product of prime numbers. So any number, you can multiply any subset of smaller prime numbers together to get that number. The exception being prime numbers. In fact, that's what makes a number prime, is if the only two numbers to produce that number are the number 1 and the number itself. So looking at 11 here, 11 is a prime number because no number from 2 up to 10 divide evenly into 11. So only 1 and 11 will divide into 11. So 11 is prime. 10, on the other hand, since it is an even number, is not just divisible by 1 and 10, it's also divisible by 2 and 5. Now 2 and 5 also happen to be prime numbers, so that's pretty convenient for us here. The prime factorization of 10 is 2 times 5. 7, another prime number, because 2, 3, 4, 5, and 6 do not divide evenly into 7. So what we're going to want to do here is, at its basic level, I think we'll want to start with 2 and work our way through the numbers 2 up until we hit the number, and see if it is divisible. And we know how to do division in Human Resource Machine. It's just to subtract a bunch of times, and then we will hit either 0 or a -1. If we hit a 0, that means it was divisible. If we hit a -1, that means it wasn't divisible, or a negative anything, really. So, with that being said, let's see if we can get started here. Obviously, we're going to need a copy of our number, which I'm just going to drop into 0 here, which we're going to call number. Alrighty. So then, they've given us a 0, which we can use to construct our divisor. We're going to want our divisor to start at 2. Call this one the divisor. Okay, so let's do our initialization of the divisor first. Copy from 0. Just going to call that 0 so it's easier to see in the code. Copy from 0, copy to divisor. and then we want to start at 2, so we're going to bump up divisor twice. Okay, we're off to a good start. So now, to get things started off, we want to start subtracting the divisor here and keeping a running copy, a working. So let's call this the work. So every time we subtract the divisor from the number, we want to bump up work. So we need to store a 0 in work to begin with. So copy to work, copy to work, copy divisor, bump up divisor. Okay, so now we want to copy from number. And I'm realizing now, as we subtract, on the chance, let's say we're working with 2 here, and we discover that our number is not divisible by 2. We don't want to overwrite this number, so we want to keep a copy of our number here. So we'll call this our. Tell you what, this will be work. The other worker we'll call temp, okay? Temp. So that temp variable will store the incremental additions. Every time we subtract a divisor, we'll add 1 to temp. And then every time we subtract, we'll store the result in work, and then we'll be able to check if work is 0 or -1. And from there, we'll be able to swap around our variables, and things should be good then. Okay, so we want to copy to number and copy to work. Now we want to copy from work, subtract divisor, and then if that is 0, we know that it's divisible, and if it's negative, we know that it is not divisible. Otherwise, we jump up here, and we want to store that. Oh, also we want to bump up. We may want to move that to before the jumps, but we will deal with that when we get to it. So that's going to bump up temps every time. We're going to see that it's divisible. We also then want to, before we bump up temp, because that's going to keep a copy of temp in our hands, we want to store that in work. Okay, so we should have enough now just to see if this works with 11. We should get down to -1, and then he'll get angry with us because we haven't finished our work, but that's okay because we are working on it a little bit at a time. It's called iterative development. So now we're going to copy from work, keep subtracting, store it, bump it, store it, bump it, store it, bump it. Sound like a Daft Punk song. Keep on going, keep on going. Now we're going to get a negative number. So we bump out. Good, okay. So if it's negative, that means it's not divisible, which means we need to bump up the divisor, and then we need to start again with the number. So we copy from number and copy to work, and then we start all over again, okay? So that's then going to, that will bump our 2 to a 3, and then we'll see if 3 divides into 11, and so on and so forth. Now, if it is 0, that means that our divisor is a prime factor. Does that make sense? No, not always. So for a number like 12, our divisor could be 6, which is not prime. So if it's 0, however, we do want to do something with it. And let's just see what happens with 10. I mean, we can figure out what's going to happen. We'll get 2, and we'll end up with 5 in temp and 2 in the divisor slot. And let's, we'll find out here. We'll copy from divisor and outbox. And then what we want to do is copy from temp to work, and then start all over again, I think. Because then we'll have, we would have a 5 in work. We would, I think let's copy to the number as well, because of what we do here. Okay, so with 10 now, what should happen? We'll do all our initialization. So we're gonna bump these down, and we'll see if we do in fact get a 5 in temp. Looks like we will, so that's good. Oh, nope, okay, so, yes, we do need to move this bump up. Into there. It's nice that they've given us another even number to work with, so we can see how that works. So what'll happen here is we will get a... negative. That should not... Back up. I think having the bump there is messing things up now. Okay, 6. Bump up. Oh, why am I bumping up the divisor? Okay. Hold the phone. Undo, please. Okay. That was in the wrong. This bump up needs to go up there. Oh gosh. Let's get some better numbers to work with. 16 is perfect because it's got a bunch of... it's basically 2 times 2 times 2 times 2. It's 2 to the 4th. So the prime factorization of 16 is 2 times 2 times 2 times 2. Because it is a power of 2. So, let's see what happens here. I'm interested to see if our logic is going to work. Subtracting there works, so that's good. This should give us an 8 in temp. We gotta keep stepping through it. This is not a fast solution by any means. Okay, so now we're going to do one more subtraction. And now see, we have the correct number there. We don't actually want to bump up temp here, so I think we were right before when we had bump temp down here. Which is confusing as to why it got messy in the previous version. Alright, we'll work with 18. We should get 2 and 9. We're gonna have to step through a lot, so bear with me here. Okay, something interesting is happening here. And that is strange. Okay, something's wrong with our logic. So let's just make sure. Copy from work, subtract divisor. Divisor should be 2. Okay. Let's work with 14. Just see what's going on. I was going through so quickly that I missed it. So we're gonna bump up temp. Oh. Okay, our bumping up of temp is in the wrong place. That's what's going on there. So you'll see we bump up temp, we get a 1, then we're gonna copy that to work. And then we're gonna start subtracting the divisor and things get funky. So let's move that guy down. That's my own fault for working too quickly and not paying attention. And we will step through. We should get a 7 in temp. Yeah. Okay. So, what we are learning here is that if the number is 0, the temp value is off by 1. So there may be a nicer way to handle this, but for now, I'm just going to bump up temp down here, and we'll see if we can figure out a nicer way to do that later on. Also, one thing to note, I believe in this level, yeah, so you can see if they give us a 7, they don't expect us to outbox a 1, which is nice. We don't have to handle that. So we can start with a 2 like we have been here. Anyway, we got a 16 again, which will be good for us to test our mod. Let's get close to 8 in temp, and we'll see how. We're going to do one more subtraction, we get a 0, we bump up temp. So now we're going to copy from the divisor into the box, copy temp to number and to work, and then start again. So now copy from there, subtract, copy there, keep on going. Oh, okay, so I see a problem. Hopefully you see it too. It's pretty obvious, but we did not reset our temp variable here, which means we're still counting up from the previous date, which is not good. That's gonna throw a wrench into all kinds of gears here. So we do instead want to make sure that we zero out our temp there. And I believe that should take care of it. We may want to zero out temp here as well. In fact, yes we do. Because that's where we start subtracting a new divisor. Okay, so with 15 we should see 3 and 5. So we'll work our way through 2 as our divisor here. We should end up bumping our divisor up to 3 after it's done here. Okay, our divisor's 3. And something just went wrong. Because we need to copy from 0, not from number. Alright. 11. So for 11 it's going to be a really long process, because we're going to have to bump all the way up through all of our divisors. You can see it is working. It's very slow. Fortunately, as the divisors get larger, we have to do fewer subtractions, so that's kind of nice. And now, there's our 11, we outbox it, reset everything there. Oh. Okay, something strange has happened, and that is that we messed up. We did not start over again. We jumped in halfway through our program, which isn't going to work. So, I think this is now working logically. We haven't seen it work on a non-prime number like 20. We're going to have to sit here for quite some time. So what I'm going to do is just stay quiet and speed this up in the edit. Alright, did you miss me? Here we go, working with number 20 now. So we should get, we should outbox a divisor of 2, then we'll have 10 as our number and as our worker, so then we'll get another 2 and a 5. So 2, 2, 5, 2 times 2 times 5, 2 times 2 is 4, 4 times 5 is 20, so 2 times 2 times 5 is the prime factorization of 20. So, working through it here, we will take our sweet time to get to a 10 in temp there. And then we will reinitialize these and start all over again. So that's kind of... Uh-oh. Back it on up, excuse me. Oh, I see. Okay, so we do not currently have an end condition here. And how are we going to determine if we have reached the end? That is a good question. I believe we've seen in the case of prime numbers, when the divisor gets to be the number in question, that we are in fact done. So let's go ahead and see if we can implement that. So here's what we're going to do. We're going to copy from number. We are going to subtract the divisor, and if that is 0, then we are done. Otherwise, this guy comes down here. Okay, so we can test that now because they've very nicely given us an even number. So we will step on through. It's going to take a while to get that temp up to 6, but that's okay. Here we go. Now he's at 6. Outbox the 2. So now we're going to copy the temp over there, copy the 0. We're going to do this subtraction. So this is to check to see if we're done. And that is not 0. So we start again. Copy from work. Do that. Keep on going. Get the 3. Okay, so we outbox the 2, and now we copy from temp and restart. Okay, so now we've got a 3 there. Now we're going to get our -1, because 3 is not divisible by 2. Because it's negative, we bump up our divisor and reset. Now we start again. Work. We get a 0. It's even. So we bump up temp. Copy from divisor, outbox it. Copy temp to number. Copy to work. Copy from 0. Copy to temp. Okay. So, I think what we want to do, because you'll see now we're never going to hit this 0 condition. I think we want to move our 0 check up a little bit so that we don't do any of this initialization for the next step through. Because in doing that, we wiped out our end condition check. So let's see how we do. We should get 2 and 2 for 4. That's good. We get a new number. Outbox 2. That's good. We get a new number. Bump for divisor to 3. Outbox it, and we should be done. They're not complaining, so I think we've solved it. But how did we do? Okay, we're over on size and over on speed. But that's okay. It's a start. We will work on paring it down in the next video. I will say thank you very much for watching. This has been A Software Engineer Plays. If you enjoyed the content, enjoyed learning about prime numbers, a little bit of the logic and algorithmic side of finding out the prime factorization of numbers, please consider subscribing, give the video a like. Ring the notification bell, you know, all those YouTube things everyone asks you to do. It really does help us out. Anyway, I will say thank you very much for watching again, and I hope you have a wonderful day. Go out there, solve some problems, and I'll see you in the next video. Thanks. Bye.